All right, hello. I figured I'd get started. It looks like no one's here live with me, but if you're watching the recording, hello and welcome. So I've prepared 5 FRQs from the officially released College Board ones. I've selected ones. They're pretty much all from units 1 and 2. So even if you're a little bit beyond those units, or even if you're not quite done with them, I thought it's kind of good review with maybe material you're pretty familiar with, so that you can kind of get how FRQs work. So obviously I should probably introduce myself. My name is Sander. I'm the stats TA here. As usual, you can follow us on all of our socials to get info about what we're doing, what we're thinking about, what we're celebrating, and opportunities, whether, that's through new community things that we're building or anything else. You can also, I believe we also now have TikTok and Pinterest, so be sure to check out us there. All right, so just a brief agenda today. I thought we'd start out by just kind of going through FRQs. And then if anyone joins us live here, I'll answer some questions. And if not, you can come back and watch this as review. All right, so let's start out with some FRQ practice. And like I said before, all of these are from officially released College Board materials. So don't worry, I'm not pirating these or anything. You can find other ones of these on the AP Central website. So if you go to the College Board and then you go to AP Central, you can find a whole list of sample FRQ sections, as the College Board publicly releases those, but not the multiple choice sections for every year. But this past one, as the modified prompts from the modified exams due to coronavirus were released to AP classrooms. You might get some of those throughout the year. All right. So if you're not familiar with how the AP Stats exam works, it's divided into 2 parts, equally weighted: multiple choice and free response. Multiple choice questions, I'll probably review at some other point. They're your pretty standard multiple choice questions. 5, A, B, C, D, E, unlike other exams where there are only 4 options, but that shouldn't make that big of a difference. So, and those will sometimes require all of the work for an FRQ, but you just have to choose what answer is right. And other times you don't actually have to do any work. They're more comprehension type. So I will go over these at some point, but today we are going to look at the FRQs. And there are 6 FRQs on the AP Stats exam, and they're broken up in certain ways. I won't bore you with the details because it's mostly confusing curriculum standard and stuff. But basically, all you need to know that there are 2 types of FRQs. There's a normal FRQ, which is just kind of A, B, and C answering questions. But then AP Stats also has something interesting called an investigative task. And that's the last FRQ. And on the investigative task, you aren't going to particularly have done a practice problem like that. It's not, covering one unit and maybe connecting it to another unit. You've got to kind of combine multiple things that you've learned through the year to solve a new type of longer problem, generally relating to some sort of real world scenario in which it's not perfectly designed for you to just be able to do one test, for instance. You'll have to kind of connect multiple things. And once again, we'll go through that later on in the course. So out of the 90 minutes, it's not strictly broken up like other exams where, for instance, the short answer questions might be separated from the essays and you can't mix them. On the AP Stats exam, you just have an hour and a half to complete all of the FRQs. And the College Board recommends you take 65 minutes for the first 5 normal FRQs and then 25 minutes for the last FRQ, that investigative task. And that breaks down to about 13 minutes per FRQ. So about 4 minutes and 20 seconds per part, but don't try and get too bogged down in the timing. So kind of what the rule that I kind of learned to work by is strive for about 4 minutes per part. So, and just kind of do what you know you can get points on. So although some AP Stats FRQs are cumulative and then C builds on B builds on A, other ones, maybe part C is a separate one, or maybe all 3 of them are kind of separate that you can answer without getting other parts correct. And I'll kind of explain more about this when I talk about the scoring next, but it's always advantageous to answer what you know is correct first. All right, so how does scoring work? So it works a little bit differently than other AP exams. And other AP exams, short answer or free response questions might be scored where you've got kind of various things that they look for, and it's kind of a scale, a little bit kind of holistically. Whereas on the AP Stats FRQs, all parts will be scored as either essentially, partially, or not correct. So A, B, and C, those will all be scored as essentially, partially, or not correct. And the way that works is if in the scoring guidelines, if you look at those for past exams, basically what those readers are looking for is they're looking for, did you include certain things? So maybe 5 or 6 things to include per part. And if you included more than 5, you get it essentially correct. If you included 3, you get it partially correct, so on and so forth. So that's why it's always important for you to A, show your work, and B, put down as much as you can. Because AP Stats, as I mentioned a lot, is all about kind of precise wording and kind of communicating math in a certain way. So always, make sure you're writing down as much as you know. If you're someone who can write really quickly, maybe I would err on the side of, writing too much, as long as you know you're not writing something that's wrong or contradictory. I would say write as much as you know to make sure you can meet all of those guidelines. Anyway, then each FRQ will be scored on a 4-point scale. So you can see that right here. So with a 4 being 3 parts are essentially correct, and so on and so forth. So this is why, like I said, you should skip around if the problem allows it. If you know that if you work for a long time, you might be able to get 1 part partially correct, and then the last part not correct because you didn't have time to really answer it. Maybe you can skip, get the last part essentially correct, which you know, and then you can come back and see what you can do there. So this is kind of a reminder to kind of work strategically on these, as the scoring is designed for you to get kind of as many points possible based on what you know. All right, let us move into the FRQs. So let's start by just kind of reading this one over. Since there's no one live here with me, I'll give kind of a short pause, but so feel free to read this, give it a think, and then I'll go through and explain the answer. All right, so if we look, we've got the sizes in square feet of rooms in a dorm at a university, and they're summarized in this histogram we have here. And based on the histogram, we've got to describe the distribution of room size in the residence hall. Now, this is kind of a prime example of what, if you know kind of what to do, it can set you really apart on the AP Stats exam. Because the AP Stats exam, you might think, oh, it's just kind of easy math. You're describing what a graph looks at. You're doing some simple algebra. But the key part about the stats exam is that you'll be kind of lost. And even if you get the right answer, you won't be scored very well for it if you can't kind of express that knowledge correctly. So here, when you're asked to describe a histogram, there are several things that they're looking for. You can't just say, oh, it's kind of roughly hump-shaped or whatever. And that's why I put this hint. Remember, CUSPS. You go back to, I believe, my first office hours. I explained that in detail. So that stands for center, unusual characteristics, shape, and size, and then BS stands for be specific. So always kind of include quantitative if you can, like measurements of things, or include relative terms, like more or less. So let's kind of think about, let's go through each of those. So for C, center, you can see that the center of the distribution is somewhere probably between 200 and 300 square feet. Unusual characteristics, well, you can see most of these fall into these 5 bars. There's not really any low bars out here, so you'd say there are no outliers. And then you talk about shape. So you can see this one, we kind of look for 2 things, shape and skewedness. So you can see this distribution isn't really skewed, but you can see there's this drop in the middle. So you can see there's this kind of 2 peak, and we call this bimodal. So we would say this is a bimodal symmetric distribution, and then the and then the scoring guidelines even say you might want to include, well, there's a cluster between 100 and 200 and 250 and 350. And then shape and size. So we've already described the shape. Now the size is that, and that's kind of, how big it is. So we would say the range of the distribution is between 100 and 350 square feet. So that's kind of how you would describe a graph. Now let's move on to this one. So read over the table and then give a think about the question. All right, so first we're asked to determine whether there are potential outliers in the data. Now in statistics, there are kind of a few ways that we can think about outliers. And there are kind of three main ways. Two based on data summary values, based on data summary statistics, and one based on a regression line. So the two kind of methods that we determine outliers given some sort of statistics about it, about the data set, are we either do it based on mean and standard deviation or median and interquartile range. So you can see here we're given the summary statistics, which means we're going to use the median and IQR rule. So a data point is considered an outlier if it is more than 1.5 interquartile ranges from the median. So to do that, first we need to compute our interquartile range. So if I get out my annotation tools here, we can see that the interquartile range is the distance between our first and third quartiles. So to find that interquartile range, we're just going to punch in 292 minus 174, and that gives us an IQR equal to 118. Now, the rule for determining if something is an outlier, according to the interquartile range, is if it's more than 1.5 IQR away from the median. So you're like, well, we don't know the data. How would we know that? Well, we know the min and the max. And because we know those, if you think about it, there's nothing going to be outside those. So if these are more than that 1.5 IQR, there are going to be outliers. So let's multiply that 118 by 1.5, which is 177, add it to the median, and we can see that there are no values that are less, or there are no values that are more than 1.5 times the interquartile range plus the median. And if we do it vice versa, we can see that's true for the minimum. You can think, well, the minimum and the maximum only give kind of the ends of the data point. What about things in between those? Wouldn't those be outliers too? And that's where kind of the word potential. So we can say that there are no potential outliers in this data, but say, what if there was something outside that 1.5 IQR? Well, then we could say there are potential outliers. We couldn't tell you what they are because there could be more than one, but we could say that there are potential outliers. Now kind of moving on to drawing the box plot. So drawing a box plot is pretty simple. So what we do is there we go. We put a line at the minimum, and then we extend that to Q1, and then we get a box that goes all the way up to Q3. Put a line in the middle at the median, and then extend another line out to the maximum. So that would be a box plot. All right, let us move on to part number C. So give this one a quick think. All right, now this one, presumably on your paper, you'd have the box plot and the histogram next to each other. So you've got the box plot, which kind of looks something like this, or the histogram rather, and then the box plot, which looks like this. And we're saying, what can we see from the histogram but not the box plot? And if you look at this, the kind of thing that should jump out at you is that the median is here in the box plot, but there aren't actually that many values there. So you can see that from the histogram that it's bimodal, but you can't really see that in the box plot. That's just kind of a quick comprehension question to see, you know, when you did that CUSPS, what kind of things did you notice there that you couldn't have noticed from the box plot? All right, let us move on to another FRQ. So this one is about regression lines. So I'll give you some time to give a read through it, and then I'll be back in just a little bit with an answer. All right, so this one looks a bit scary at first. There are quite a few things, but let's kind of break it down piece by piece. So if we read kind of what we're given, we're looking at the relationship between the number of customers in line and a checkout and how long it took them in seconds to finish it. So we just kind of looked and they measured the time. And they graphed this, we got a regression line, and then we got this printout of data. So identify and interpret the estimate of the intercept for our least squared regression line. Now this one, all it's asking is, do you know how to read this funky table down here? So basically, to find the intercept, we're looking at the constant, and then we need to look at the coefficient. So that's just basically saying, what's the number? So 72.95, that's the intercept. And if we think about what this means, well, if we look here, that's saying that there's 0 customers in line. So you would say, well, it is estimated that the average time taken to finish checkout, if there's nobody in line, is that 72.95 seconds. And here the really crucial thing here is to get kind of a full name of your explanatory variable, and then get your full units of your response variable. So make sure you're specifically saying what exactly you're measuring. So customers in line in seconds. All right, on to parts B and C. So give these a quick look and then I'll answer these together. All right, so again, these two are pretty basic. It's just kind of checking if you kind of understand concepts. So identify and interpret the context of the coefficient of determination R squared. So it's pretty easy to tell that you're looking at this R-SQ, so 73.33%. And how you interpret the coefficient of determination is it's how much of the regression line, you know, how much of the variation from the regression line can be explained by this line. So what you want to say is that 73.33% in the variability of the time it takes customers to finish checking out can be explained by knowing how many people are in line when they first got in line. So you've got to kind of include, basically say that the R squared value explains this much of the variability in the times it takes to do this based on knowing this. All right, so now I mentioned before for part C that there are 3 ways to know an outlier. I kind of lied to you, there's a 4th. And the 4th is when you're looking at, or never mind, I didn't. I said there were 3. So the way that you look at an outlier for a regression line is you just eyeball it. Because a regression line is, you know, designed to be the best model. This LSRL is designed to be the best possible model of this regression line. So there's really kind of no reason for you to perform some sort of test, because this is already kind of the best possible estimate. So we would see that there's this guy right here, and you would say that that's the outlier, and you would say it's an outlier because the value greatly differs from the rest of the data. So you can see, so you'd say something like, you know, the expected value if there are 3 customers in line would be much higher than shown here. Therefore, it's an outlier. All right, let's move on to this next FRQ. So give it a read over, and then I'll take you through the answer. All right. So this question, we have data being collected, and we don't actually know anything about the data, but we're looking at the relationship between the length of a wolf and the weight of a wolf. And when we make a scatter plot, we can see that the relationship between the two variables is positive, linear, and strong. So this is just kind of asking you to comment on what each of those words means specifically in terms of statistics. So here, wording is crucial. So when we say that the relationship is positive, that means that we're saying when one goes up, when their explanatory goes up, the response will also go up. So we're saying that longer wolves will weigh more. And then when we talk about a linear relationship, that means that there's kind of a constant relationship. So we would say that as length increases by, say, 1 meter, weight will also change by a constant amount of kilograms. So what we're not saying is that it's nonlinear, so that how much increases varies on where you are along the length. But here, we're saying roughly as it gets longer, it will always weigh the same amount more. All right, and then strong simply means that it falls close to that line. So that's where you would say if it's weak, it means they only kind of loosely follow that line. All right, let's look at parts B and C. All right, so here we're given this least squared regression line, and we're asked to interpret the meaning of the regression line in context. So what this slope means. So you can see that the slope here, one kind of important thing to notice I should mention is that in statistics we write linear relationships as y hat equals a plus bx rather than y equals mx plus b, as you may be used to seeing in algebra. And this is just kind of because if you think about statistics, their values are very rarely negative. So we're always going to start at an intercept and then either go up or go down. And then another kind of crucial thing is that this hat means when you see hat, always think predicted. So so this is basically saying what's the predicted y. And how you interpret a slope is you've got to be kind of very precise when you write it. Again, you've got to kind of include our precise units. So we would say that the slope means that for every increase in 1 meter of length in the wolf, the weight will increase by 35.02 kilograms. And an easy way to kind of realize that is at 0, this will be 0, so it's got 16.46. But then when this is 1, it'll increase by 35.02. All right, this next one is a little bit more complicated, so I'm going to give you a few seconds to kind of think about it and see if you can come up with. All right, so in general, so let's kind of look at what we have. So we've got a length of a wolf, and we know what the residual of it was. So we're asking what the weight was. First, let's kind of think about what a residual is. So the line will probably look something like this. And we're saying, given a length of 1.4, the residual was negative 9.67 kilograms. So that's the distance between the actual point and the predicted point. So in other words, based on this value, we know that the actual value was 9.67 kilograms lower than what would be predicted. So basically the formula there is the actual value is equal to the predicted value plus our residual. So we can say, well, what's our predicted value? Well, it's going to be this. And then we can add on our residual. So we would say to get that, we would say take our negative 16.46 plus 35.02 times 1.4, and then add on our negative 9.67, and then we would get our predicted value of 22.898 kilograms. And again, if you didn't follow, it's just some simple substitution. So this is the formula for relating actual, predicted, and residual. So, and then we substitute in our least squared regression line for that y hat, and then we're given the residual. All right, so that's kind of a tricky problem in that it's kind of one of the few times in statistics where you have to combine formulas. And again, it's important to make sure you're getting your signs straight. Make sure that you subtract this because it's less heavy because residual is always actual minus predicted. So let us move on to another FRQ. So this is kind of similar to the first one. So read it over and give it a quick think. All right, so this is just another kind of simple CUSPS one. So first, let's think about the center. So we would say, well, the median tip amount, it'll be somewhere in between $2.50 and $5. And you can do this based on how many are in each year, how many are in each bar. So if we know that there's 60 tips, the median will be between the 30 and 31st, which will be somewhere in this bar here. So that's how you calculate median in histogram. Unusual characteristics. You can see that it looks like there's kind of an outlier or a potential gap here where there's this extra tip upwards of $20. And then we would say shape. Well, it's not bimodal, but there's this clear slant here, and that's a skew. And to tell whether it's skewed or left or right, look which tail is elongated. So here we can see how the right tail is very stretched out. And this means that it is skewed to the right. Kind of a neat trick I learned from my teacher was that you can kind of remember also which way it's skewed by looking at your feet. So you can see if you compare the way your left toes look, kind of the way they'll curve down, that's skewed to the left. And if it looks more like your right foot, in which the shorter part is on the right, then it's skewed to the right. Obviously not perfect, since most people's toes kind of curve like this rather than like this. In terms of going along, but it's kind of a nifty trick that I learned. And then, so that's shape and then spread. We would say they range from 0 to 2250. All right, so next one, this was talking about how outliers or how changing data amounts affect your central tendency measures. So give this one a quick think. All right. So first, let's think about how the mean would change. So the mean, if that had been greater, well, let's think about the formula. So the formula for mean is all the numbers summed together divided by how many there are. So if we think about what an increase in $10 would do, well, that would increase that overall total by $10 but there would still be the same 60. So it would increase it by 1/6 of a dollar, which is about 17 cents. All right, now the median. Think about what the median is. The median is the central value. So if something from here had been moved to here, the median wouldn't actually change because both 8 and 18 are greater than the median, so it wouldn't shift it in any way. All right, let's do one last kind of interesting FRQ. So here's how you compare two box plots. So first, if we compare the medians are about the same. But if we compare our interquartile range and range, we can see that they're both greater for corporation A, and corporation A also has these nice two outliers out here. So let's now think about part B. Suppose you're offered a job at $36,000 a year, and you want to think about which job you would rather have. So to kind of think about this, first let's look at what we're actually looking at. So you can see basically what we're looking at the box plot of employees at two companies who were hired for the same starting salary, and we're looking at what they're now getting paid 5 years later. So one thing that we might look at is we can say, hey, now the minimum salary for B 5 years later is $41,000. But corporation A, it's still down here at $36,000. So for example, I might want to work at corporation B, because although at corporation A you have the potential to make more, you might just stay making the same amount. And no matter what, on average, the average person will make about the same amount no matter which company they work at. So I might work at corporation B because although I don't have the potential to make as much, I do have the potential to make more than I started. All right, so that's our presentation. I hope you've enjoyed it, and it's kind of proved useful for you as you answer your own FRQs in practice. So if you've got any more questions, join our community Slack. I've got a whole channel dedicated to stats, and any of your questions can be answered there. So thank you all for watching.